It's the second week of January, and the Snapmaker U1 is my favorite printer so far this year. Joking aside, if you got the Kickstarter early bird deal like I did, then you paid just $750 for a printer that's just slightly larger than the Bamboo P series, but you get 4 individual tool heads to print with. This is my favorite printer in my workshop, but it isn't all sunshine and roses because we have some growing pains Snapmaker should address, but luckily, not many of those issues were hardware. So we're gonna unbox, set up, verify their claims that this Dragon prints 6 times faster with 5 times less waste compared to my P1S. We're gonna test the finest 0.08 layer height. My favorite use case so far has been PETG supports with a PLA print without any waste. We're gonna run our normal out-of-the-box speed test to find out just how much you can get without actual tinkering. And we're gonna talk about some areas for improvement. But first, if yours isn't printing quite right, you need specialty materials, or require tolerances from industrial printers, then head over to PCBWay. Take your STL, upload it, choose material, color, threaded inserts, assembly, and more. Finally, choose how many you want, and you can save the more you need. 3D printing isn't all they can do, with CNC machining and custom PCBs are just 2 of the literally dozens more products they have. Use my link in the description below to save $5 off your first order.
Let's get to unboxing, and of course step 1 is to cut open the box. Once open, you're able to pull out a smaller box with 4 spools of PLA with Snapmaker's RFID tag built in, which tells the printer what exactly is on each spool. Unfortunately, there was no good way to lift the printer, so I'm laying it on its side to pull it out. My table is small, so I'm trying to be very careful, as you should be too. Once it's out of the box, start stripping away the remaining cardboard, bubble wrap, tape, plastic covers, and double check you have it all. You don't want to find out you missed something when you try to start it. Then we head inside where you'll find a box with your parts in it, like spool holders, print heads, and PTFE tubes. With the box out of the way, look for stickers with arrows because you'll have to remove these screws before powering it on. Reading the manual, as everyone should do, we're going to start with the motors that move the filament through the PTFE tubes. Each one has numbers corresponding to each side of the printer, so double check those match with the manual. Connect the ribbon cable, slide it on to secure it. We'll be connecting the smaller PTFE tubes from the motors to the underside back of the printer. The second set of tubes is much larger, so you can't get these mixed up. The hardest part of the spool holders was keeping it aligned as it gets inserted, and I had to use an uncomfortable amount of pressure. Make sure the numbers match again because I don't see an easy way to redo this step. Our printer poop catcher is inside instead of purging to the outside like many others. I think this is fine. As you'll see, we're going to have almost no waste. In fact, I never emptied it until after printing everything for this video. All right, the exciting part, our tool heads. Make sure you read the instructions carefully because I didn't. One print head has a label on it, and that's the first one you'll install because it's different than the other 3. When used, it detaches in a different direction. Before installing each tool head, make sure the metal slider inside shows the red marks, and if it doesn't, you can use anything to move it until you do see those red lines. As you're looking at the printer from the front, this tool head will go to the far left because to detach it, the U1 will move it to the right, unlike the others. The manual has good instructions on how to slide it on and positioning the metal dowel. Repeat for each other tool head, making sure that red is showing before you're done. The top PTFE tubes and cables were the most painful only because the 16 small screws you need to put in. Once it's all together, it's pretty firm and flexible as you need each tube and cable to be. Now we can start the setup with the power switch on the back, which is next to a USB port, and more interestingly, an expansion port that you'd find on like a Bamboo AMS or a Creality CFS. Very interesting. I prefer English, I'll select global instead of China, logged onto my Wi-Fi, some terms and conditions I read thoroughly, I promise you, and get into calibrating. While this was never a quick process on any printer, you're going to do this 4 times on the U1. We can load our filament in anticipation by slapping it onto the spools, and once you insert the filament to the motor, it'll grab and go for you. The calibration isn't fully automated as it pauses and asks you to scrub the nozzle. Maybe not necessary after just unboxing it, but it can't be truly sure after something like a factory reset, so I entertained it and moved on. You'll also need to remove the build plate and reinstall it when asked to. Website has a metal circle with a label Smart Calibration, and it's there under the build plate. Finally, each head will auto level and we can get printing. For my first print, I need to know if the marketing for this Dragon stating 6 times faster, 5 times less filament is true. Since @IK3Digital is credited on the website, we can go find him and download the model. First, my P1S took about 16 hours to print, which the website said, quote, other, quote, printers took 30 hours. So I have no idea what printer they used, but they did say 0.4mm nozzle, PLA, 0.2mm layer height. The Snapmaker U1 took about 3 hours, meaning our estimated performance over the P1S is 533%, which is very close to the claimed 600% faster. Shouldn't be hard to hit their goal with a slower other printer like my K2 Plus that I swear purges a whole roll of filament between color changes. Speed is great and all, but I can run that overnight. Filament waste is where my money gets thrown away. Snapmaker claims 5 times less filament, so let's put that to the test. I'm going to include the U1's calibration you should be doing with new filament, but is technically optional. The P1S does purge before printing too, but it purges just 1 nozzle compared to all 4 nozzles in the U1 when you run calibration. I was astonished at the result. Before even weighing anything, look at the piles of waste. The P1S weighed in at 219 grams, which is less than half the, quote, other printer on the website. Now the Snapmaker Dragon at just 54 grams. This is a net savings of 165 grams, 16% of a roll of filament, for 4 times less filament, or about 75% less waste. Snapmaker provided the perfect colors to print a Pikachu, so we're going to use default settings, and I want to check out the quality. I've learned that after a certain price point, quality plateaus, but it's good to test anyway. Honestly, watching these toolhead changes is, well, I could do this for dozens of minutes. As I'd expect at this price point, layers are even, colors separated and defined, no failures, but a few filament boogers that are easily picked off. Not disappointed. Stock settings are great and all, but I've never tested ultra fine quality 0.08mm layer heights. I don't have a use case for this, and you should be using a smaller 0.2mm nozzle, but those were delayed, and I'm working with what I got, so let's see what I got here. Printing overnight with supports may have been a bad idea. At 0.08mm, the gap is so small the supports are essentially melted into the model, so there are a lot of spots here I couldn't get them off. Looks great where I didn't give up on supports though. This does remind me, PETG and PLA don't stick, so it's common one will be used as supports for the other. With 4 tool heads, we don't have to purge every layer, and this should be a breeze, so let's test that. I don't buy a lot of PETG, but if this works, I might have to, and it did. Sort of. Printing and pulling apart a test object work great, As soon as I bumped the test PLA, it wiggled free from the PETG. I've never tested this and was just floored. So let's try a more complex object, and well, it went less better. As you can see, our purge tower collapsed, resulting in a lot of boogers as it attaches extra filament to the model. My theory is that we're purging PETG and PLA in the same tower, but as those two filaments aren't really that sticky, eventually a little nudge broke it free, and now we're printing in thin air. Dang. I was able to clean this up and look presentable until I broke the leg. Oops, sorry. Let's try again, but with all PLA, and she turned out great. Maybe this isn't the solution I'm looking for, but it'll definitely get used for complex models with a lot of supports. Moving on to my personal favorite, speed tests. In all slicers I've used, there's an option to tell the printer, I want you to print 25, 50, or even 66% faster. Most software will still account for parts of the model it really should slow down for, which is what I prefer because we can measure how efficient that is. Solval will just give you whatever you ask for, like when I asked it to print 500% faster, it didn't go well. Anyway, a boat is to test a high detailed object, and I have a cube to test a simple object with large straight lines. Snapmaker lets you pick 150% in the slicer, although you can go much higher on the printer's web host if you want. The boat was disappointing at 3.7% faster, which compared to Bamboo's best time on a P1S, 27 minutes at 17% faster. Quality seems to be the same as I'd expect at 3.7%, and if it differed, that would be hugely disappointing. The cube is next, and also disappointing at 22.4% faster. Again, my P1S holds the crown at 7.5 minutes for a 36% increase in speed. But again, this is all free performance on the table, so take advantage of it. If you're mass producing single color prints, then maybe Snapmaker isn't quite it. Things have been pretty positive so far, as it should be. Remember, you're getting 4 tool heads for under $1,000. While the H2D is fully enclosed and more polished, it's also 2 tool heads for $2,000, or the H2C for $2,400. So the U1 is a steal. My only issue that may not be software related was with the Deadpool Pikachu. I wanted to print it at max height, and the slicer approved it and sent it. The U1 would then fail after the first letter with some abnormal axis movement error. I shrunk the model to the size you see in the video, and it printed just fine. Just changing its scale was the only change I made after 3 attempts. The issues I'm confident are software related can be fixed are with the Orca slicer. I wasn't able to automatically sync the loaded filaments like I can with Creality, Anycubic, and Bamboo. After selecting the filaments that are loaded, you then have to assign numbers on the Prepare tab. Not a huge deal, and allows for a little more control, but I'm not really a fan. In the Orca slicer, you can't download your time-lapse videos for now. I'll say for now because as a developer, this should be easily fixable once the issue is prioritized. You have to note your printer IP address, go to that address, and download your video from there. When I opened Orca, I'm frequently asked to log in, as if my credentials are only valid for like 24 hours. I didn't actually measure, but I find myself constantly logging in. When I do log in, my U1 is available as a cloud printer and has to be selected. It's my only printer. Why aren't we automatically selecting it? More of a missing feature instead of a bug, I can't load and unload filaments from Orca. I have to do it from the printer itself, which is still easy, but like when I want to swap my black PLA to black PETG for that section of the video, I couldn't do it as I was also preparing the models. Keep in mind, all these issues can be solved through patches and feature updates, so the moment those start rolling out, this section will be out of date. I'm super excited to continue printing with the Snapmaker U1. The 4 tool heads is fascinating to watch and makes you wonder what the next big feature to come to 3D printing will be in the future. The software can be fixed, but you can't fix hardware once it's out there, so far, the hardware has been phenomenal. I'm really curious what will happen with that expansion port, and I would be all in on an AMS type system with a new mount for the filament motors so I can put it on the shelf above the printer like all my other printers. There is a top cover I ordered for $150, which was delayed and pushed back along with nozzles and other items. $150 is expensive for what it is, but its MSRP is $250, which is crazy. And I absolutely wouldn't pay that, but I also have other enclosed printers for ABS and other specialty filaments. If this is your only Core XY printer, maybe it's still worth it. That is up to you. However, 99% of the time, I'm printing PLA or PETG, so I don't need it, but I want it to test it. So subscribe for more, like the video if it helped. Thank you, and I'll see you later.